Hello everyone. Before we get started, I want to give a big thank you to DJ Berg, one of the subscribers. He made the intro screen and the exit screen for us. We really appreciate that, and so a big thank you for your efforts there. Well, it's finally came in. We ordered this Planetary 550. It's an NSK product. It's a high-speed spindle. I believe it'll get up to about 65,000 RPMs. And this is what we've been talking about in some of the previous comment sections and some of the people that I had correspondence with, is that we were going to turn this surface grinder into a high precision ID grinder, as well as what you'll see in the future. We're actually with the faceplate that will have it's in the process of being built. We can make it a limited jig grinder, a high precision jig grinder using a faceplate and a proper clamping system and gauge blocks, and you'll be amazed at the accuracy that you can get off a setup like this. And we were going to buy a brand new unit. I've used this in the past probably, I'm going to guess probably 20-25 years ago. The Planet 550, it's a good unit. We've had that. That's what I tried to get this time, but then when I called and started checking on things, I was told they don't make the 550 anymore, but they make the 600. And I contacted American Rotary Tool, and I talked with Wolfgang over there, and I'll put a link in the comments section if anybody's interested. But the Planet 600 is a better unit even than this. They got a collet system, which in the 550 was always the weak point, even though it was a great setup. The collet system would really only pinch on about 1/4 inch of your shaft. And what would happen with the 600, they got a single angle collet that goes in there instead of a double angle, and I believe it's going to choke up on more of the shaft of your AD wheels and stuff and give you a lot more rigidity. Well, we had to make this unit, and we had to make this unit so that we could hold this. Basically, you pull the guarding off your wheel and the guarding. You use the same holes as your guard, and you just need to get a unit like this. They can move with the bolt hole clearance up and down a little bit, and I got a screw here and a screw here, and I can adjust it here a little bit, and if for whatever reason, if I wanted to really kick it at a big angle, I can remove the back screw. It's a 3/4 inch shank that's going in there. I'm holding it by 2 points, and I want to talk about that a little bit later when we get to Fusion 360 to show you something you might want to consider if you're going to build something like this. But anyways, this unit, they don't make the 550 anymore, and so we saw that on eBay. We seen that they had some used ones for sale, and so we decided to go this way for now. It was within our budget. This unit on eBay we got for $900. The Planet 600, if you're interested in that, it will come in a box like this, and in this box you're going to end up having air filter, and you're going to have an oiler, and that oiler has to be a special unit because it needs to atomize the oil. If you're running straight oils like in a pencil grinder and stuff, and then the bearings won't work as efficient. So if it's atomized, it works pretty nice. So this is set between 20 and 30 drops of oil, but not all of that is going through there. It's again, the way they got it set up, only a portion of that is going through there. So if you bought the Planet 600, and you get the box, it'll come with an 1/8 inch collet and a 1/4 inch collet. It'll come with the regulators, all the tools you need. I believe there should be some stones, all the different things, the hoses. The nice thing they got on their exhaust, they got a little muffled system over here, so it's not that loud. I believe that will be close to $3,200 for everything. And for what it can do, in my opinion, it's quite a bargain. And as you can see, what we have done over here, we did ID grinding. We did this OD grinding, and we're going to show some pictures of this. On the OD, because my wheel's quite a bit smaller than this, and it was very loaded up, I have a little bit of chatter on that, but you can work that out. Other thing that's nice about this setup, if you really wanted to do it, and the way we have done it in the past as a business, we would get a lot of our work, we would set up and we would grind the OD on the surface grinder with our unit facing this way, and we just do the OD work with a big 8-inch wheel and get the best finish that we can. And what we would do for anything that needed ID work, later on we would turn the unit, pull the guards off, set everything up, and then we'd re-indicate in the fixture off the face and then off the diameter and grind the ID concentric to the OD. So we would save our ID work so that we would have, you know, maybe a day or two of work at a time on that, because it will take approximately, when you get good at it, 15 to 20 minutes to take the wheel and the guard off, that you get this unit up. And I got this set right now where you can indicate down on the bottom here and indicate across here, and it'll line up really well. But it'll take about 15 to 20 minutes, so you don't want to do that if you have, say, a dozen of these. You're going to be adding 20 minutes to a part. So grind the ODs off first, flip it around, change it over to ID, re-indicate it up, and if you get good at that, you can indicate them in quite fast, and then you can grind the IDs. But it's a nice, easy way. If you already have a surface grinder, by adding one of these, now you've got the ability to do ID grinding. And as you saw, we've done this angle, and I got these precision 45 degrees, 45 90s. I got these 30, 60, 90. As well as what you can do is you can throw against your back rail, and that's what I do on these angles, which are common. I just use that against the back rail. Center line of this is lined up with this edge real nice. I can get some real precision angles, and if it's not an angle that I have a template made for, I can always throw a sine bar behind there and get whatever angle that I need. And as you can see in the picture, it's just a beautiful finish on that angle. And the ID, we could have an even better finish, but because we were trying a number of things in order to get this video out, we did grind quite a bit out of that hole, which surprised me, because we're using a stone wheel and we're using an 1/8-inch shank. And the reason we're using the stone wheel and the 1/8-inch shank is because when this unit, we bought it, it was used. If you buy a new unit, you're going to get an 1/8-inch collet and a 1/4-inch collet. This unit came with 2 1/8-inch collets. I didn't have a 1/4-inch collet. We have one on order. And so with a 1/4-inch collet, I'm going to have a lot more rigidity. I can use bigger wheels, and I'll get even better finishes than what you see over here. And not only that, I like using CBN wheels. You can rough these holes out quite a bit faster. They'll last a long time before you have to true them up or dress them. Where stone wheel, if you're going to take something over here and grind 15 thousandths out, you're going to have to hog most of that stock out, and then you're going to have to set something up to dress the wheel out, come back and to get your finish that way. With the Borzon, most of the finishes that we need there, or that our customers would want, is more than adequate, and you don't have to do that in between dressing. You can grind for weeks that way. So anyways, I was really surprised again, because of the 1/8-inch shank, and this wheel being kind of large for an 1/8-inch shank, how well that worked. But if you're grinding some really small holes, in the past I would grind holes that were probably about 90 thousandths in diameter, and we would grind them real precision. What I use for checking our holes, we got some precision gauge pins over here, and it's really nice because you can take a pin that's 1/1000th under, and you can get it fitting real nice in the hole. And if you have a set that goes by every 5/10 thousandths of an inch, you can get some very precise hole measurements using these pins like this. Not only that, you can feel as you slide these pins in, you can feel if it's tapered. You can feel that in the pin as well, so you can tell how straight you're going. So anyways, when you're done with your angles, you can pull this out, slide that back up. Now one of the things that I had a problem with, the unit I used to have before was a little bit smaller, The motor didn't have this coming out, so I didn't have any problem with the clearance here. So right now, I don't have a lot of travel when I have this unit set up in this way because I have this here. Now there's a couple ways I might deal with that. One, I may make a bracket that comes up and comes over, and I think I'm going to do that sometime in the future, and actually have it resting on top here with the weight. So I have my motor mounted on top, and then I can slide that back and get more distance if I need it. The other thing, I built this so that you can actually flip this block upside down. I can turn this 180 degrees and I have all the clearance over here, but that just feels awkward because in my entire career I'm always doing my ID grinding from this way, and it's just going to feel odd doing it that way. But I got those two options, but I think I'll make a bracket that will mount this motor over the top, and then I can slide that quite a bit further back, and I think that will work better for us. I want to show you one of the things that we've done on Fusion 360 over here for that 3/4 hole that we mounted. For a lot of you guys who have never used Fusion 360, I've ran quite a few different CAD programs in the past. This is one of the nicest ones I ever run. What's nice with this package, not only do you have one of the best CAD packages, it's also running a CAM package, which is pretty much the same thing as HSM Works, which is a nice CAM package, especially for milling. And with the CAD, I'm not an expert in it, but I tell you what, the little bit I've done, I love. It's very user-friendly. The other nice thing about this, if I understand their license agreement correctly, if you are a company making $100,000 a year or less, then you can get this for free, and that would be us. The other thing is if you're just kind of a hobbyist, you can get this entire package for free. And in this package you have the modeling, which we're on, the patch, you have the sheet metal, you have the rendering, animation, simulation, you got the CAM, and then you can actually make detailed drawings out of everything over here. This is cloud-based, so what's nice about that is it will save you work to the cloud, and you can get apps for even like your telephone, or if you're visiting a friend or something and you want to show them something, they got a computer, you can log on to your account, and you got that at any place you got a computer or a telephone, if you got the apps set up on that with one of your smartphones. A very powerful piece of software. Very easy to use, very easy to change and manipulate things. So what I'm going to show you right here is this is what I used to design just to get my dimensions, and I found out that if I draw this up, it saves me from making things 2 or 3 times over, because I can see what mistakes that I'm going to make. If I'm just trying to do this out of my head, I can see them, I can catch them here. Saves me a lot of time. But if you look at the hole that's over here, you can see what I got going on. I actually have 2 holes in here. What will happen a lot of times if you have just a round hole and you're taking a shaft, this is just slightly under 3/4 of an inch, about 2 or 3/10. If your hole, let's just say if your hole is 750 right on the money and that shaft is 750 on the money, you cannot put that 750 diameter, you cannot put into a 750 diameter hole. They're sized the same. So the shaft has to be a few 10,000 smaller in order to fit into that hole. And so what I did, I bored this hole out just as close as I could get it. Now what will happen is if you have that hole just even perfect, it's still a 1/10 or 2 small. What happens when you put a screw in over here and in the back and you tighten down, and if this was a perfectly round hole, what happens, you have 2 points of contact. You have 1 point of contact on the tangency on the back side of where the screw is going to be pointing or putting pressure, and you're going to have where the screws actually put pressure on the front side. So you have 2 round circles, one is a few tenths smaller than another, you end up with 2 pressure points, and so what can happen, you're going to lose some rigidity in there. And a lot of times if you're running a lathe with boring bars, you'll find that you'll get this. You think, why, this bar fits so good, I got it tightened down, but I get chatter. I can't stick my boring bar out, I can't get anything. A lot of it is because you got a 2-point contact and it's not holding this solid. So what you can do over here, once I bored this hole out, got it to the size I needed, I backed the boring head down 10 thousandths, and then I moved it over in that direction 7 thousandths, and so it's taken about 2 thousandths off, but you can see what it's doing. This is all clearance that's highlighted there. It's giving me a tangent line here and a tangent line here, so now I have a 3-point contact, and things are a whole lot more rigid. And let me see if I can find a sketch on that, and I can show it to you a little bit more. Let's see, which one should I have these named off? Yeah, I think it might be that one. So here's what you can see. I went 750. Of course, I'm about 3/10 smaller. What I bored it to, but I just drew it out at 750. That's what this diameter right here is. This diameter is 750. This diameter right here, this little piece, is at 740. So what happens is I backed the boring bar off 10 thousandths, and then I moved in that direction 7 thousandths. And so what it does is this is all clearance right now. All that you see in the blue. So now I got my screws pushing over here, and at that point, that's where the shaft is making contact. Now I got a nice rigid 3-point contact system. And if you do this with your boring bar holders and different tool holders and stuff like that, where you have chatter problems, you'll be surprised at how much better that will work out for you. So anyways, this is the project that we've been excited about, that we've been wanting to show for quite some time. I haven't seen anybody else use a system like this. Maybe they have, I just haven't seen it. I looked all over YouTube. About 20 years ago, we've done this on a different company that I was a part of. We used this for years, done excellent work. You wouldn't believe the high precision, accurate work that we've done. And if you're interested in that, look at the links below at American Rotary Tool. Give Wolfgang a call and talk to him about one of these units and what he can set you up with. When you buy this unit, this one I think is at the setting I have right now, it's about 57,000 RPMs. I think it'll go up to 65. But they have units that go up, I know, I'm pretty sure it's at least 120,000 RPMs, and you can check on the American Rotary Tool website. You can check on that. But when you get the ones that are the higher RPMs, you can get into these really small wheels. The smaller diameter wheel you got, the more RPMs you're really going to need to get the surface footage up proper, to cut proper. We're going to probably be doing some future videos on that. Like I say, we got a faceplate that we're working on, but I think I'm going to use this. And I'm going to see if next week I might be able to do a plate in there and jig grind 2 holes with the spacing in between that nice and accurate, just so you can see the functionality of this and how nice it works. Again, you can have, with a unit like this, if you have a surface grinder, with this unit, a nice spin fixture, depending on your setup, faceplate, V-block, you can end up now with ID grinding, OD grinding. You'll be able to do limited jig grinding. There's a number of times I would bolt square blocks up in here that just need a hole located just right. This system, again, you're limited to your size of your swing and everything, but for a lot of that smaller work, it works good. So we hope that you enjoyed the video, and we'll see you next time.